3.2a is on ratios. So a fraction always shows a part to whole relationship, never a part to part. A ratio sometimes shows a part to whole relationship and sometimes shows a part to part relationship. So when we're talking about ratios, there are a couple different ways we can express them. We could say, if we wanted to, looking at example 2, we can write the ratio of 1 car laps to 2 car laps in 3 ways. So if we look at when car 1 goes 1 lap, car 2 goes 4. So for every 1 lap car 1 goes, car 2 goes 4 laps, which means car 2 is going a lot faster, right? It's going 4 times faster. So we could express this ratio by saying it's 1 to 4. We could do 1 colon 4, but we still read this as 1 to 4. Or we could write it as a fraction, where again we'd still read it as a 1 to 4 ratio. So these are 3 different ways to write our ratios. So all of these, right, for ratios, they could show a part to whole or a part to part relationship, but whenever we're using a fraction, that's only a part to whole relationship. So this is just a lot of vocabulary right now. Let's look at a couple of examples so we can really understand when it's appropriate, or how what notation is appropriate for these situations. So if we look at our example 2 here, here's our problem. If there are 12 girls in a class of 26 students, what's the ratio of girls to total students in the class? So we're talking about the girls to the total students. So this is a part to whole relationship, okay? Because part of the class is girls and the whole class is 26. So this could be 12 to 26. Okay, it would be our part to whole here. And if we simplify that, right, 2 goes into 12, 2 goes into 26, that will leave us with 6 to 13. So we say we have a ratio of 6 to 13, or 6 to 13, or 6 to 13 for every, right, there are 6 girls for every 13 students. Now, if there are 12 girls in a class of 26 students, what is the ratio of girls to boys in the class? So this one, we're talking about girls to boys. Now, this is a part to part relationship because part of the class is girls and part of the class is boys. It's not the whole, because we're not talking about the whole 26 students. We're talking about the half that's girls and the part that's boys. So let's think about this. If there are 12 girls and there are 26 total, well, 26 minus 12 would be 14. So if there are 12 girls, that means there are 14 boys. Okay, so our girls to boys would be 12 to 14, but we can simplify that, right? We could divide both of these by 2. We could say that there are 6 girls to every 7 boys, or we could say there's 6 to 7 is our ratio. Now we can't write this one as a fraction because it's a part to part. So we're saying that there, for every 6 girls, right, there are 7 boys. That's our ratio relationship in this class. Let's do a couple more examples. We want to make a comparison with ratios for the set of cards. So the ratio of cards with hearts to the ratio of cards with diamonds. So hearts to diamonds. So this is a part to part, right? Because what are we talking about? We're talking about the different cards. So if it was all cards, that would be our part to whole. But this is just the hearts to the diamonds. So we're talking about hearts to diamonds. And if I'm looking at these cards, I see that I've got 1, 2 with hearts and 1 with diamonds. So this is a 2-to-1 ratio, which I could also write as 2-to-1 with my colon. All right, ratio of cards with diamonds to cards with clubs. Well, again, this is a part-to-part relationship. I'm going to put part-to-part to abbreviate it. So my diamonds to clubs, well, we know there's 1 diamond and there's 1, 2 with clubs, which we could also write as 1-to-2. So that's our part-to-part relationship for diamonds to clubs. Ratio of cards with hearts to ratios of cards with clubs. So now we want hearts to clubs. Well, we've got 2 hearts to 2 clubs. 2-to-2, that could simplify to a 1-to-1 relationship, or 1-to-1. Ratio of, let's do one more before we move on. Now the order matters, right? Our diamonds to clubs ratio is 1-to-2. Our clubs to diamonds ratio would be 2-to-1. So the order does matter when you're talking about it, right? You have to be thinking about what you're saying, right? What comes first, what comes second when you're talking about these or reading these. So 2 more, these last 2 are talking about the ratio to all cards, okay? All cards, so these are part to whole. Okay, what's our whole? We have 1, 2, 3, 4, 5 cards. All right, so if we want the hearts to all cards, well, we know we have 2 hearts to 5 cards, or 2-to-5. And then we have the ratio of spades to all cards. Well, we have 2 spades to 5 cards. So again, that's 2-to-5, which we could write as 2-to-5. Now, since these are part to whole, we could also write this as a fraction, 2-to-5. Same for our hearts to all cards. We could write as 2-to-5. All right, a couple more examples here. 2 more examples. We want to write the ratios. If there are 14 apples in a bag of 26 apples and oranges, what is the ratio of apples to total fruit? So total fruit, this is a part to whole relationship because we're talking about the part that's apples out of all the fruit in the bag. So our part is apples to our fruit. Well, there are 14 apples to 26 apples and oranges. So our ratio would be 14-to-26, which we could also write as 14-to-26. Then since this is a part to whole, we could also write it as the fraction 14/26. We could also simplify this, right? Because 2 goes into both of these, so we could write this as 7-to-13 as our ratio. Now, if there are 14 apples in a bag of 26 apples and oranges, what is the ratio of apples to oranges? All right, well, this is a part to part because part of our fruit is apples and part is oranges. So our apples to oranges, well, if we have 14 apples and 26 total, 26 minus 14 would be 12. So this is 14 apples to 12 oranges, which we could also write as 14-to-12. Or we could simplify this to 7-to-6. Right? 7 apples to every 6 oranges. We can't write this as a fraction because it's a part-to-part relationship. Last example, at the movies, the ratio of small popcorn to large popcorn is 4-to-9. For every blank large popcorn, there are blank small popcorns. Okay, well, if the ratio of small popcorn to large popcorn, small to large, is 4-to-9, that means I've got 9 large and 4 small. So for every 9 large popcorns, there are 4 small popcorns. Last but not least, at the baseball game, the ratio of hot dogs sold to hamburgers was 5-to-4. So we've got hot dogs to hamburgers, 5-to-4. So that means there are 5 hot dogs and 4 hamburgers. So for every 4 hamburgers sold, how many hot dogs were sold? 5 hot dogs. So again, the order for your ratio matters. It matters for your numbers, right? Which one they are related to, which comes first, which comes second. So pay attention to that when you are